Hi everyone. In this video we are going to see our next part of solved gate question paper 2024. Previously I have released two videos in which we have covered four questions and this is the fifth question. And this question is under the topic worst case time complexity. We can expect at least one question for an exam for exams. So this is the important topic. Let's move to the question. The question is given an integer array of size n. So there is an array with size n. We want to check if the array is sorted or not. It can be in ascending order or descending order. The array has to be sorted. We have to check whether it is sorted or not. And for this we are going to use an algorithm that solves this problem by making a single pass through the array and compare each element of the array only with its adjacent elements. So this is the simple algorithm. For this algorithm, the worst case time complexity we have to find. Worst case time complexity of this algorithm. And they have given the options. So this is very clear, simple question but important question. Let's go to the answer. So here we have to check whether the array is sorted or not. So if an array to be sorted, the array does not, if it is not sorted means the array does not follow any consistent order. And it will be not be in both ascending or descending sequence. If the array is sorted, then it will be either in ascending order or descending order. In ascending order, the array is sorted from single to largest values. That is, each element should be less than or equal to its successor. If the array is in descending order, the array is sorted from largest to smallest values and each element should be greater than or equal to its successor. So this is the scenario for the given question. And we have to find the worst case complexity to check whether this array is sorted or not. So the time complexity of an algorithm designed to determine whether an array is sorted either in ascending order or descending order, the worst case time complexity we have to find. Also, it should take single pass through the array and compare each element with its adjacent element in both ascending order and descending order sorted. So let's analyze the computational complexity involved in this process and find the worst case complexity. To determine if an array of size n is sorted, we need to perform comparisons between adjacent elements. In computational complexity theory, we have big O notation representing the upper bound limit of the running time and omega notation to represent the lower bound limit of running time. So this is the time complexity bounds for a comparison algorithm, that is comparing adjacent elements algorithm. So the upper bound limit is big O notation and lower bound limit is omega notation. Here what they have given, it is a linear time, linear array sorting method. Why? Because in this we are going to check each element with its adjacent element and find whether the array is sorted, if it is sorted in the ascending order or descending order. So since the algorithm make a single pass through the array, it will perform a linear number of comparisons, especially n-1 comparisons as we have n elements. So here what it will do, array of n elements it will take, then perform n-1 comparisons, that is comparing each one with its adjacent one and check it is sorted or not. If it is sorted, it will say yes, array is sorted, otherwise array is not sorted. This is the working of this algorithm. So the worst case scenario in the linear time complexity of array sorting check is, we can tell both O of n and sigma of n. Why? Because the worst case analysis is why we can tell O of n. It is usually for a linear, linear time complexity of array sorting, it is big O notation, O of n. But why we are taking here sigma of n means the algorithm must examine each element at least once to determine if the array is sorted. So it is examining each element with its adjacent element at least once. So the worst case time complexity is sigma of n also. So the algorithm's worst case time complexity is both O of n as well as sigma of n. So what is the time complexity of sorting check algorithm? That is checking in a single pass through the array is both O of n and sigma of n. O of n means the algorithm's operations grow linearly with the input size, and sigma of n means the algorithm must examine each element at least once. So the answer is both O of n, sigma of n. This is the answer for this question, and we can expect this type of questions at least one question per year. So hope you understand the video. And please subscribe for more solved gate questions. Thank you.